So today we're going to go over problem set 5 of CS50, and problem set 5, there is just one programming prompt, and that is the speller. We actually have to build in a speller that detects miscapitalization or misspelling of words. Before we jump into it, one disclaimer: this video is for educational purposes only. Cheating or any other form of cheating is highly discouraged. These videos are only for students who are looking for inspiration or looking for other approaches to solve the CS50 prompts, but it is not for those who are already solving the problem sets and are just copy pasting some of the code. So that's just with that disclaimer. Let's get started. So in this particular programming prompt, what we're going to do is we are supposed to build a speller. Okay, so let me open the programming prompt here. So we go to week 5 and we go to problem set 5 and we have the speller. Okay, so in speller here, what we're supposed to do is we're supposed to build a data structure. Specifically, we're supposed to build a hash table, which basically detects the misspelling of words. And luckily, the CS50 staff, the code that they provide you, takes care of most of the stuff. We only have to write 4 or 5 functions, and those are pretty short ones also. Okay, so luckily most of the stuff is pretty straightforward. So let's jump right into it. Okay, so for this particular problem, the walkthroughs are super helpful because they practically give out the solution, but in English. All we have to do is translate that the English language into programming constructs and programming code. So yeah, so let's get started by downloading the CS50's problem set 5. So what I'm going to do is I'm going to go here, create my present directory is in sync. So I'm going to go ahead and create the problem set 5. So I'm going to do make directory problem set 5. And I am going to go into problem set 5 and do all that wget stuff. So wget this guy right here, actually, yeah, so I'm going to do this, and I'm going to unzip speller.zip and then remove speller.zip folder and then change directory into speller. Okay, so that worked. And then so here's our given files that we have to work with, right? We have dictionary.c and dictionary.h and speller.c. All we have to do is complete the functions written in dictionary.c and we're good to go. Okay, so let me open that. Okay, so this is the dictionary C that they give you, and we have to complete like 5 functions that they give us. Okay, and luckily the CS50 staff, the walkthroughs pretty much says how you have to do every single thing. So let's go through that. So I'm not gonna play the entire walkthrough here, but I believe so this is a high level overview, and then the second is the load. So Brian starts off with this load function. So let's go ahead and implement this load. They practically say how you should do it, and these are the following steps. So we have to open the dictionary file, read strings from a file, blah blah blah, right? So let's start with step number 1, open dictionary file. Okay, so let me go ahead and do that. Okay, so this is my load function, and I'm passing the dictionary, which consists of the file name pretty much. So all I have to do is first open the dictionary, right? So let me go ahead and do that. Okay, so open dictionary file. So how do I open dictionary file? I just used fopen, right? Fopen, I pass in the dictionary and I say I want to open for reading, and this returns to me a file pointer. So I say file equals that, and I have to make sure and see if it's not equal to null, right? So let me go ahead and say if not file, or I can also say file is equal to null, right? That means an error occurred, so I return false, saying that the file could not be opened. Okay, else what do I have to do? Okay, so else I read the strings from file one at a time. So how do I read the files? So let me just copy that. Okay, read one word at a time from the file. Okay, so how do I do this? So even for the answer for this is scanf. Brian practically tells you in this video. like so. Okay, so you have to use fscanf, and then the first argument is the file that you're reading from, and this is the format specifier, in which case we're reading strings or words, and this is the buffer that we're going to fit into. Okay, so let's declare this buffer first. We already have the file that we have previously declared, so let me go here, and what I'm going to do here is I am pretty much just going to declare the buffer here. So char word, which is going to be a buffer, and what should be the size of this buffer? We could put something like 100, just some arbitrary max number, or we can look at what dictionary.h defines to be the max. So let's go to dictionary.h here, and it says length is 45. That's the maximum length of a word. So let's put say length +1 just in case, for like a null terminating character. Okay, so that's the length of the max word. Okay, and what we're going to do is we're going to do scanf. Okay, so we're going to do go here and use this line. Okay, so fscanf file, fscanf, and your first parameter is the file, second parameter is the format specifier, third parameter is the buffer, which we declared here. So when we do that, while we want to continue this while it's not equal to end of file as specified here. Okay, scanf will return end of file once it reaches the end of file. So while it's not equal to end of file, we want to start reading words, right? Reading words. Okay, so far so good. Now what do we have to do? So if you go back here, not this part, I believe. Okay, now I have to create a new node for each word. Okay, how do we create a new node? Using malloc, right? So create a new node. Okay, so I'll just say node new node equals malloc, and size of it should be size of the node class here, so node structure. So I'll just say node. Okay, and then what we can do is we have to check whether if new node is equal to null, right? Same idea as the file guy here, like the file check here, we return false. So we return false. Okay, else we can copy over, the word over the word to the node, basically store the word in the node. Okay, so we'll say new node, we'll say stir copy, basically these functions. I think even in the video they specifically say what to do. If I go here, they specifically say node n equals malloc blah blah blah, and string copy and word equals hello, right? So let us just copy this. N word is, instead of hello, it would be copied from word, right? And then we also set new node dot next is equal to null for now. Okay, so now that's done. Now what do we do? Okay, so we follow these steps. Now what we have to do is we create a new node for each word, hash word to obtain hash value. That's pretty easy. So all we have to do is say int index equals hash, and we pass in our word, and that will give us our hashing index. Okay, obtain hashing index. Okay, once we obtain our hashing index, what we have to do is insert the node into hash table at that location. Okay, so what we can do now is say, okay, so even before this, let me just quickly explain about this data structure here, right? There's an array of node pointers, right? Basically array of linked list. So it's going to be something like this. So say this is our array. So this is going to be node 1, node 2, node 3, node 4, right? Say assuming size is 4, this is the head of the linked list 1, head of linked list 2, head of linked list 3, and so forth. So what we have to do is say we obtain the hashing function, and it gives us the first location here. What we'll have to do is pretty much check if it's null. If it's null, then since we created that new node, we place it there. So just assume for the sake of our argument here that the size of this array is 4, right? So say there's 4 elements in this empty array. What we do here is we actually say the hashing index gives us index number 1, right? We look at index number 1, it's equal to null. So what we do is we populate that with our new node that we just allocated here, right? Which is this guy right here. Okay, so that's what we'll do here. So we'll say if the table at index is equal to null, right? Then what we're going to do is we're going to say table at index is equal to the new node. Okay, so that takes care of the scenario here, right? But what if in the next iteration the new node also hashes into the same exact location, so we have a new node here? Okay, how do we deal with that? We have to, in that case, what we have to do is do something like this. We have to actually append a new node, and we have to put this new node, say new node 2 here, okay, assuming it hashed into the same location, because we're building our linked list. Okay, and the way we can do that is actually we can insert at the front of the list. Okay, so instead of, actually this is the example that I've written, I've actually inserted the word at the back of the linked list, but I guess even in the walkthrough they recommend you can just insert at the front of the linked list, which would make it probably easier. So how can we insert at the front of the linked list? We just have a pointer here already, since we dereferenced at that location, right? So all we have to do is carefully move the pointers over and put node next 2 here and node next 1. So remember that we're inserting at the front of the list. Okay, so that's what the walkthrough recommends, so we'll do that. And they even say how to exactly do that. The best part about this walkthrough is that they practically give us the code, and all we have to do is just implement some of the stuff here. So I believe, where do they put it here? Yeah, so what they do is what we have to do is we should just say new node.next is equal to table at index. That's the first step, and then we say table at index is equal to new node. Okay, so we do this step first, right? New node.next equals table at index. So table at index is a head one, and then we say table at index is equal to this guy right here. That's what we pretty much have to do here. So this is the else scenario, right, where we're inserting at the front of the list as explained here. Okay, so let's go ahead and do that. If you didn't understand that part, just watch the walkthrough here. It's pretty straightforward. Okay, so we'll say new node dot next is equal to table at index, which is pretty much the head, and we'll say the head is equal to new node. Okay, and that's all we have to do. So that's pretty much it regarding the load function. So yeah, that's all you have to do in the load function. So let's move on to the next function after this. Let me mute this so that accidentally doesn't, okay. So the next one is the hash function, and this just pretty much returns a numerical index between 0 to n minus 1. So you can use any hash function you want, but they practically give you some example hash function, and we'll just pick this one, the third one, math using all the letters. So what I'll do is I'll just use hash function that just sums up all the ASCII values of the letters. Okay, so if it was ABC, it's just going to take the integer value of the ASCII character A, integer value of the ASCII character B, and then integer value of the ASCII character C. So ABC will be like a particular sum, so it's going to be 65 plus 66 plus 67. Okay, and we're going to use that as hash function. So let's pick this third one here, math using all the letters. Okay, so let's go ahead and code that. Okay, so I'm going to go to this hash function here, and I'm just going to code the hash function. So I'm going to say for int I equals 0, I is less than strlen of word. I'm going to iterate through word, and what I'm going to do is I'm going to sum up all the ASCII values. So I have int sum equals 0, and I can just say sum plus equals word at I. Okay, this is going to capture the ASCII value. You don't explicitly have to cast it to an integer, because underneath the hood they are stored as ints. So this will capture. So if you pass in something like ABC, so what will happen is, it will take the ASCII value of A, ASCII value of B, and ASCII value of C, add them up together. Okay, so at the end of this loop, we're going to have the sum of the ASCII values. The only thing that's left is that it might exceed the total n here, right? So we have to adjust it accordingly. So what we'll do is we'll just simply say sum mod n. Okay, so that should be that should make sure it correctly, it doesn't go over bounds. Okay, so after we do that, then what we can do here is pretty much n is still 1 here. That's a default value they set. So we have to think about how many buckets we're going to create, right? So we can easily do that because they give us the maximum word length, right? So in this case, it'd be 45. And assuming all those 45 have take the maximum ASCII value, which in this case would be lowercase z, right? And while we're at it, why not do lowercase? Because I don't want to worry about uppercase, lowercase. So I'll just make sure I do everything in lowercase. Okay, so I do everything in lowercase, and the maximum word length is actually in this particular problem, it's 45. So I can just so if all of these are z's, like z or z, however you want to call it, then the maximum ASCII value will be the ASCII value of z times 45, right? That's the maximum ASCII value that they'll possibly exist. So I'll go ahead and do that. So I'll say length times the ASCII value of z, and I'll just do +1 just in case, you know. I mean, just to make sure it's big enough. I don't actually have to do this, but just to make sure it's big enough. Okay. So actually, let me put it here, maybe. Something like this, right? And then I'm gonna create that much spaces in my. I'm gonna create that much buckets here, and allocate that much buckets. And I have hash. When I hash into it, it's pretty much present. Okay. So then what I'm gonna do is that's pretty much my hash function. So they practically tell you how to do it. If you want to use other hash functions, you can just look at various sources on the internet and just cite it, and yeah, you can just use that. Okay, so that's pretty much it regarding the load function. After load function, they talk about size, and I believe you can just watch the walkthrough, but he pretty much says that there's multiple ways to do it. One is just to iterate through this entire array that you've allocated, and pretty much like look for words and just sort of start summing up the total number of words in each bucket, right? That's one approach. You can do that. You have to write more code, but the easiest way would be to have another variable that, say, like it's called total words, that you increment as soon as you add the word into the data structure here. So recall that in load function, we load all the words to a array, right? So let's just increment the words here. So after we do this, we just increment total words here. Okay, so in that case, as soon as it adds the words into our data structure, it's just going to increment the total words here. So when we get to size here, all we have to do is just return total words, and we're good to go. Okay, so that's pretty much it. And it's going to return 0 if it's not yet loaded, which is the case because I initialized it with 0 here. Okay, so that's that. And the next function after that is called check. We want to check whether what it does, it returns true, the word is in the dictionary, false otherwise, and it's case insensitive, right? So they pretty much say these are the steps. So actually this particular programming problem is really easy because they practically tell you what you have to do. So hash word to obtain hash value. Okay, that's straightforward. I go here and I say int index is equal to hash of word. Okay, and I don't have to worry about whether this word is uppercase or lowercase because my hash function already converts everything to lowercase. So you could, I mean, if this was just summing up uppercase and lowercase separately, there's a possibility of that having a different ASCII value and stuff like that. But I make sure I just always cast a lower value here, and I don't have to worry about making it lower again here, or creating a copy of the word and making it lower. Okay, so that makes my code a lot more simpler. Okay, so I obtain the hash index here. Then what do I need to do? Then I pretty much go here and I say access linked list at that index in the hash table. Okay, so now I have to just iterate through that. So I'll just create a temporary here, and I'll just say table at index, right? So this gives me my temporary variable, and traverse the linked list looking for the word. Okay, how do I traverse the linked list? They pretty much say that part, how to do that part also. So they say cursor, you have to use this value called cursor. So I say node cursor equals table at index, while cursor is not equal to null. I keep on traversing by calling cursor equals cursor.next, right? And at any point of time, if I see that the strings match, then I have to return true, right? That's the gist of it, right? So what I'll say is you use this function called stir case CMP. stir case CMP, and you pass in cursor.word, and then you pass in the word, and if that's equal to 0, then the strings match, so you return true, saying that the word is in the dictionary, right? Else you keep on looping through, okay? And once you loop through, if you find that it does not exist, you return false, okay? So yeah, that's pretty much the gist of this guy right here. Yeah, they pretty much tell you how to do everything here. So all you have to do is just translate that into code. Start with the cursor and set to first item, keep moving until you get to null, checking each node for the word. That's exactly what we do here. So after this, we have to just do the unload function, and we are pretty much done with this entire program. That's pretty much it. So let's go ahead with the unload function, and all we have to do is just free the memory here. So we have to free the linked list, okay? So let's say free the linked list, and all we have to do is just follow this diagram here. So they have the head here which point towards the head of the list, so let's initialize that. We'll say node head equals table, or sorry, we have to iterate over our entire array here, right? So like say this, there was new nodes here, new node 3, new node yeah, I don't know, 4, something like that, and this was empty or something. We have to iterate through this entire thing, go through each individual linked list for each one of the elements here, go through it, run through it, and free it, okay? So all we have to do is just do for int I equals 0, I is less than n, I plus plus, and what you have to do is you have to free each linked list, right? So how do we free each linked list? They pretty much say how you do it here. So we just say node head equals table at I, and what we have to do here is so this is my head pointer. I also have a cursor pointer, so I'll just say node cursor is equal to head, and I think they also have a temp pointer here. So they say this you have to be very careful while freeing, because if you free this, then you lose your references. So make sure you watch the walkthrough. You just have to be careful and just follow the walkthrough pretty much. Okay, so I do this, and I have another variable called temp which points to head. So I say node temp points to head. So then I have to start freeing my linked list here. So how do I free it? They pretty much say it here. So I first advance the cursor forward, so that's the first step I'm going to do. So I just say cursor equals cursor next. Then what do I do after this point? The next step, second, is freeing the temp. So I just call free temp. So I freed the temp. Now what I have to do is move the temp over. So now after this step, the temp is going to join with the cursor. So I just say temp equals cursor. And yeah, that's pretty much it. We have to repeat this until the cursor is not equal to null, right? Because I believe, yeah, cursor equals null, and then it'll be that's the end of the list, right? That's pretty much it. For this particular programming problem, they practically give you the code. So I don't know why this particular programming problem is particularly difficult, because they practically say how you have to do every single thing. So all you have to do is just translate the code. They even give you in code in some places here, which is kind of awesome, I guess, or however you want to look at it. But in any case, that's pretty much it, I believe. Let me check the return values quickly for each one of them. So check, yeah, so check returns true if it's found, false otherwise. Hash should return an integer, so that's fine, because we mod it, so we make sure it's within the valid range. For load, it returns false if it's not, if there's error, and this should be true, I guess. If it comes here, it's true because then it's successfully loaded. For size, it returns total number of words. This is Boolean. Once it frees, this should be true actually, because it successfully finished releasing everything for unload. Okay, so that's pretty much it. Let's try compiling it now. So we'll do make speller. Okay, we have tons of errors, so let's step through this and see what each error means. Okay, so first one is, let's see here, excuse me, null, undeclared null. Okay, so is it because, okay, we have to import some library. So let's import standard lib.h, standard, we used lower also, so ctype.h, include string.h. What else do we need to include? file. Okay, stdio.h. I don't know if this is necessary, but CS50.h. Anything else? Staircase comp. Okay, where is this defined? Staircase comp CS50. Strings.h, which is kind of confusing actually, because there is string.h and there's surprisingly strings.h, which is, I don't know, kind of weird naming. Okay. And then after this, what was the other error again? We have undeclared use of n. So that's where here. Oh, this should be new node. Okay, new node. Okay, so now let's make it. Okay, cool. So we're good to go. So let's quickly test it out. How do we test it? We run this guy right here, I believe. Okay, so it looks like it's doing something. Okay, let's check if this is the right one. So what they recommend you to do is they also recommend you to run against the staff solution here. Okay. Oh, actually, we should have probably. Okay, so I'll say instructors.txt. This is the instructor. And then I have to also create a student.txt. This is our, oh, sorry. Oh my God. Okay. So this is the instructor.txt and this is our student.txt. And now we have to just diff it, right? So we say diff y this. Diff y instructor. They call it staff, I guess. Instructor.txt and student.txt. Okay, so we did something wrong here. Or did we? Oh, no, we didn't. Okay. Let me just put diff, just normal diff of something like this. Okay, so it looks like all the words are correct. The counts are matching up. And looks like our solution is kind of slower compared to their solution, which is fine. Probably we can improve the hash functions, but ours is a really simplistic hash function. We just sums it up, sums all the ASCII values and all the letters up. So it's probably not a good hashing function, but hey, it works, and the functionality wise, it's fine. It works as expected. So let's try submitting it now, and let's check 50 first, I guess. So let's do this, and just to repeat again what I did. All you have to do is just watch the walkthrough for this one and just translate every step that the walkthrough says into code, and you should be good to go. I don't think there's any additional surprises or any of gotcha kind of thing for this particular programming prompt. It's pretty straightforward. So let's check. Program is free of memory errors. Valgrind test failed. Rerun with log for more information. So it looks like we leaked the memory somewhere. So let's check exactly where we leaked the memory. Okay. So this is fine. We malloc here. This looks fine. We have to also close it, right? We have to close the f close. I don't know if that's also needed here. File. Does that solve the problem or no? Let's check. Yeah, we had opened it, but we never closed it. And since it's also a pointer here, so I don't know if this will fix it, but let's check. Waiting for results. Come on. Okay, I guess that's just a small error. Okay. Yeah, so it passed all the tests, so let's try submitting it now. Submit 50 and we pass in this. Okay. So yeah, while it's submitting, yes. Okay. So while it's submitting, let me quickly explain what we did. So we initialize, and so our hash function is just going to be the sum of the ASCII characters, and that hashing function was given to us in the walkthrough, so we just implemented that. I just converted to lowercase to make sure I don't have separate if clause for uppercase, lowercase, and just makes my code a little simpler. And in order to check whether a given word is in the hash table, we just have to hash it, and we just have to go through the linked list, the particular bucket, and just see if the word is present in the bucket by just iterating and following the notes. The load is the crux of the problem, I believe, because it would just read the word and malloc and sort of allocate memory to it, and allocate memory for the notes, and then walk through the notes one by one. In size, we just return the total number of words because we kept this counter here. And that unload is also a tricky function to implement, but fortunately the CS50 staff pretty much give you the code how to do this in their walkthrough. So I think a pretty straightforward problem set, because of the fact that in the walkthroughs they practically give you all the code and pretty much the entire steps that you need to do in each function. So it's really straightforward. But if you guys have any questions about this particular approach or video, just let me know. And let's see how we did here. We got 9 out of 9 for speller, so that's good. Okay, so I think it passed all the cases, and then style 50 is 0.96. Okay, so hopefully this video helped you. And like I said in the beginning, this video is only for educational purposes, and by no means you're meant to copy paste or directly write out the code that I have presented in this video. However, you can get inspiration from this, or you can also if you have finished the problem set, you're more than welcome to look at other hash functions or different various approaches that other students have taken to solve the problem. But that's only after you finish the problem set. So hopefully this doesn't break the academic honesty code, and hopefully this was helpful on some level to you guys. So yeah, so that was pretty much it with this speller. Pretty cool assignment. I believe there's also like a leaderboard where different students submit their different speller implementation, and it ranks the different speller implementation. So that's also pretty cool. And I believe Brian is one of the top 10 or someone somewhere along those lines. So pretty cool stuff. So let me know if this video helped, and stay safe, good luck, have fun coding CS50, and make sure you challenge yourselves to new approaches and thinking about problems in new different ways. Okay, all the best and good luck.